Okay, continuing to the next part of radiography testing, which we saw last time. We saw X-ray radiography. Similar way, there is something small topic in your syllabus is called gamma ray radiography. So again the concept is pretty much simple. Similar way, slightly this is even more faster method. So there is a particular diagram which you should draw. Okay, please draw this diagram. So the concept is again pretty much in parallel with previous thing. There is some X-ray source, gamma ray source. So it is like, because it is radioactive material, it emits the gamma rays in all direction spontaneously. So what happens is, this can be even much faster. At a time you can have multiple testing getting done. So this is the square thing is shown as a casting, which is a sample basically, and just after that there is a photographic film. So this is photographic film, this just line is shown as a photographic film. So this is the situation. So what happens is, it is like a circular symmetry, and it can be just one after another. So what the idea is, people keep feeding the person who is working there, he keeps feeding these different samples and different films. So by the time it rotates and again comes back to the same position, it is already exposed to the gamma rays, and already that film is ready to be analyzed further to get the information about this casting. So just write few lines, this is small topic. So just write this. Gamma rays are emitted in all directions. Unlike X-rays, gamma rays are emitted in all directions. Therefore, large number of separate castings can be tested simultaneously. Full stop. Each with photosensitive film on its back. And of course, the diagram is needed. You can pause this video and draw the diagram. After you draw the diagram now, after exposure for several hours, write it down. After exposure for several hours, film is developed and separated radiogram are obtained, So this was all about gamma ray radiography. Okay, the next topic is flaw detection. So it is similar to the sonar what you have learnt in the previous standards. So flaw detection, basically we want to measure, suppose this is a sample and I want to find out if there is flaw anything inside which I cannot see inside this material in this depth. To find that, we can use ultrasonic sound. So the idea, I will just draw the diagram quickly. Okay, so this is typically a diagram. The concept is again pretty much simple. So suppose this is a specimen, this is the sample what we have, this is the sample, and we want to, and it has some flaw inside in this depth. So suppose this is a irregular shaped flaw. What we do is, there is a transducer. Transducer means it can reflect, it can transmit as well as receive the any kind of particular waves. For this case we are talking about ultrasonic wave. Anyway, I cannot write this now. Ultrasonic waves. So this can emit ultrasonic waves as well as receive ultrasonic waves. So the point is, there is some high frequency generator, because why high frequency? Because ultrasonic is a high frequency sound. So high frequency generator, it gives the signal to this transducer. There is also in between, so this transducer is fixed to the specimen on the surface. So it's like a, suppose this is a specimen and this is a transducer, it will be fixed like this, but only to make this proper contact there is a thin liquid layer actually which uses which works as a good medium of contact. So typically it is oil. So there is a thin layer of the liquid in between transducer and the specimen. This is a flaw. So what happens is, these transducer emits ultrasonic waves. So these are shown as these ongoing rays. what happens is it reaches to the another side and gets reflected. But for wherever there is a flaw, it also gets reflected even in between. So this is an extra signal. So what happens is after this get these waves getting reflected in from all these points, transducer can sense those, receive those. There is amplifier which enhances those signal, and those are plotted on the CRO or any kind of analysis material instrument. What you get is typically you get only for that particular part you get small less intensity signal, because some signal is absorbed. So that is the basic principle. This is how we, if there was no flow, the signal from all direction would be constant. So just write, so this is the basic principle. Please draw this diagram, you can pause this, and now you have drawn this diagram, please write some of the important lines. So write it down, write it down. Ultrasonic pulse is produced by exciting the transducer from signal generator. From signal generator, wave is made to travel through the specimen. Reflected waves are received and reflected rays are received. Time of transit and amplitude is displayed on the CRO. Full stop. Pulses will be reflected by defects like flaws or cracks. Full stop. If a defect is present, there will be another peak. So I could not draw this well, but this you can give this as to show this is A and this is B. So this first peak is A, this second peak is B. So if a defect is present, there will be another peak, this small peak, which in the diagram we have shown as B. I want to write this here B, but my ink is gone. So please even in the writing write it B. There will be another peak B. Time delay between two pulses can be measured, and position of the defect can be calculated. Position of the defect can be calculated. So you can also find out the position of a defect can be calculated by formula D equal to Vt by 2. D equal to Vt by 2, where V is velocity, T is time lapse between the peak A and peak B, this and this. T is time between the lapse between peak A and B, and of course divided by 2, because it is twice distance it has to cover, so we have to also compensate that. Okay, there are a few advantages. I can wipe this off. There are a few advantages. Just write down the advantages. Oh, this is now gone. Advantages. They can be used for any size and shape. Please write this down. They can be used for any size and shape. Next, even if one face is available. Next, even if single face, FASCE. So not both faces are, just some part is available, you can still find out the defects inside. So you can put that transducer only for the available face side मला म्हणायचं आहे. ठीक आहे. Even if one face is available, you can it can be used. Next, only one coupling is required. Only one coupling. Coupling means only one side you have to, it's like a coupling. When you are putting transducer here, you are making a coupling. So only one coupling is, दुसऱ्या साईडने आपल्याला काही नाही करावं लागत. अनलाइक एक्सरे रेडिओग्राफी, तिथे काय करावं लागतं, इकडे पण ठेवायचं, इकडे पण ठेवायचं, दोन साईडला तुम्हाला लागतात गोष्टी. ओके. नेक्स्ट, डिस्टन्स ऑफ द डिफेक्ट कॅन बी ऑल्सो मेजर्ड. Distance of the defect can be also measured. So this was all about the flaw detection. So, pretty much we have covered all important part. There are one last point I wanted to take in this chapter, which is acoustic emission testing, which I will take tomorrow, and we will finish this chapter tomorrow as well. So, we can start the further part. Okay, thank you very much. Be safe.